Hello friends, today we want to find out the range and the time period for a projectile which is being launched in a horizontal direction. So say this is we are having a tower which is having, say, the height is h, or any surface with a height h, and we are launching this projectile with a velocity v in the horizontal direction. Now what will be the path of the projectile? The path of the projectile will be something like this. G acceleration is acting on this in the downward direction. So under the influence of gravity, it will slowly fall down, and also it will cover a distance r in the horizontal direction before hitting the ground. Therefore, I want to calculate the range and the time period for this projectile. So let's find out. First of all, we'll define the axis. This is the x-axis and this is the y-axis. For the initial velocity, let's take the components. Ux, that is the x component of the initial velocity. What is the initial velocity? Initial velocity is this v. This is entirely in the direction of x. So ux will be v. And uy, that is the y component of the velocity, that is 0, because there is no y component and the entire velocity is in the x direction. Now let's write the equation of motion in terms of distance. X will be equal to ux into t plus half at square ax into t square, but ax is equal to 0 because the only acceleration acting on it is acceleration due to gravity, that is entirely in the minus y direction. So x is equal to uxt plus half axt square, ax 0. Therefore x is equal to ux into t. So I have this expression, x is equal to ux into t. Now let's focus on y. Y is equal to uy into t plus half ay into t square. What is uy into t? First of all, it is y is in the minus direction, so I will take minus y because displacement is in the negative direction. It is coming from top to bottom, and here if you see, here we have taken the upward direction as positive y-axis, but displacement is happening in the downward direction, so we'll take the negative y. Minus y is equal to initial velocity is 0, uy 0 into t plus half, again g is in the minus direction, half gt square. So I can write y is equal to half gt square. So we got another expression, y is equal to half gt square. So after manipulating it, after separating t at one side, we can write t is equal to root over of 2h by 2y by g. So this much is clear for us. So let's remove this part. Now for y is equal to, okay, let's eliminate this t. Let's eliminate this t. So x is equal to ux into root over of two y by g. Now for y is equal to capital H, x is equal to r. Let's write it here separately. for y is equal to capital H, x is equal to r. This is very evident. This is evident from this diagram itself. When that projectile is falling on the ground, it is completing a displacement of h in the negative y direction. The projectile also moves with a displacement of r in the positive x direction. So I can say when y is equal to h, x is equal to r. So we can just replace this in this equation. R is equal to we have ux is equal to v into root over of 2h by g. So we got the range. And time period, what we have? Time period. For time period, let's replace this y by h. We can just make a small replacement here in this equation. This small t I will put as capital T, and this y I will put as h, because for falling down the full height h, the time will be time of flight, that is t. It is time of flight, not time period. The time of flight will be t. So that's all. Let's solve a question. We have been given the same scenario, that is a projectile is being projected or launched from the top of a tower with a velocity v in the horizontal direction. Now we have to calculate the angle of velocity as it strikes the ground. That means let's draw the path. At this point, when it is striking the ground, we have to calculate the angle the velocity will make with the horizontal. Now let's find out. Now we have ux is equal to v and uy is equal to 0, and acceleration is in the downward direction. Now what will be the value of vx? Vx is ux plus ax into t, but we know that ax is equal to 0, so axt will be 0, this full term will be 0, so definitely we don't need this term, we can make it 0. So vx will be equal to ux. So the horizontal component of the velocity will not change throughout the motion. This we have also seen in the normal case of projectile motion, where a projectile is projected from the ground and it returns back to the ground. This is simply due to the fact that in the x direction there is no acceleration. Now we have to find out what is the velocity component in the y direction. Vy is equal to uy plus ay into t. So Vy will be, what is uy? Uy is 0. Ay is, see, velocity will be having a component in the downward direction. I am assuming Vy is in the downward direction, like this is Vx and this is, say, Vy. So Vy will be 0 plus g into t. So I can write it down as, let's remove this, Vy is equal to gt. So Vx is equal to, I can say V, and Vy is gt. So I can write the velocity in vector form as velocity as a function of time, v I cap minus gt into j cap. Why minus gt? Why not plus? Because it is in the negative y direction. Now the angle it makes with the x-axis. We can find out the angle like this. The angle will be this is, let me draw it again. This is Vy, this is Vx. The projection will be, the resultant will be here like this, and this is V. The angle it is making here is theta. So this is nothing but tan theta is equal to Vy by Vx. Now we have seen Vy is gt and Vx is V. So this is the angle it will be making at the point of collision, point of striking the ground. Now what is t? What is the time period I have shown already? So by that formula we can find out this angle. This angle will be tan inverse of gt by v. So thank you for your hearing, and if you like our content, please subscribe the channel.